Hello everyone, this is Jeff Z. And today I'm going to share my learning experience of the LeetCode problem 933, number of reason calls. So it is an easy problem. Um, so let's jump into the description and then we can talk about my thought process and um, how I wrote the code versus how LeetCode what's the LeetCode solution is. So this is this is like a more like a class design question. What you see is it asks you to design a class which called reason counter to count reasoned requests. It has only one method, pin, where t represents some time in milliseconds, right? And return the number of pins that have been made for uh, 300 milliseconds ago until now. So basically, it's always going back to 3,000 milliseconds back and get all the panes. And any pane with time is basically say t minus 3,000 till t will count, including the current pane, which means if you paint this right now, this pane will also be included. This is guaranteed that every call to pane uses a strict large value of t than before. All right, so which means it's incrementally uh, increased. The t is incrementally increased. It will not happen that the t is suddenly smaller than previous t, right? Okay, so the example one, so you have this pane. So the first is actually the first input is so the first input is 1, and then the next one is 100 and 3001 and then 3002. So what happened is the first time you call pin, it should return 1 because including itself, it only has one hit. And if we're going back to 3000 milliseconds before, and the next call, the next pin is at the time of 100 milliseconds. So if you go back to 3000 milliseconds before, so what you will get is itself plus you know the the hit you made on at the 1 millisecond time. Um, so if you go back to 3000, so then the next one is 3001, which actually gonna go back to 3000, which is like at so the the hit on the 1 millisecond will be also included, as well as the 100 for sure, and then um, you make a hit on 3001, which is at that which is the current one, will also be included. So in this case, it will return 3, which is these three, right? 100 and 3001. Then the next call is actually the next hit, the next ping, sorry. It's actually 3002, which is going back 3000 milliseconds ago. This definitely itself will be included, and this one is just 1 millisecond ago, so it will also be included. And then the next one is 100, which means that it's about 2900 2 seconds ago, which gonna be included as well. But this one will not, because this one is definitely out of this 3000 milliseconds window. So the answer of this one is also 3. Yeah, so each test case, so there's some note. Each test case will have at most 10,000 calls to pin. Each test case will call pain with strict increasing value of t. Each call to pain will have 1 smaller equals to t smaller equals to uh, you know large number. Yes. So this is actually my thought process of how I solve this problem. So first thing is I'm not sure if anyone know the hit counter problem, um, but this seems like a very similar problem to the hit counter. So there was one thought I have is I should use a fixed array because I don't really care about what happened before 3000 milliseconds, like out of the 3000 milliseconds window. So I may have a fixed size array, sorry, which is 3000 elements always, um, and uh, I marked this as not optimal solution. The reason is when I submit the solution, it seems that it's not, if you see, this is actually what my solution is. So it's, I'm not at the, yeah, so where is me? Mm, yeah, memory, so runtime is a little bit high. I don't know. Yeah, the percentage, you see that people are usually like spending, yeah, spending like less than 100 milliseconds, less than 50 milliseconds, which is not my solution, and I'm like 10 times slower than them. And the 68 where I am is pretty much also, memory is pretty much high as well. um, so So yeah, go back to the original saying is sorry, original solution. So this is one idea that I have, and another is there was one thing I miscount is it should always contain itself. So don't forget about this. And the next thing is I fixed this current saying, and then um, as I said, it's low rank. I checked this LeetCode solution. It shows that it's using the queue, which is pretty simple idea actually. So the queue um, is actually I think in this case it's more efficient because um, I assume that you will not have like very heavy calls. If you have very heavy calls, the queue may have, for example, every single second it will have, let's say, every single millisecond it will have like 100 calls uh, to this pane API. Then you need to think about if you're going to use a fixed array or a queue. Um, yeah, so I mentioned this, and also I actually tried the queue solution, but the queue solution seems that it's the similar performance as my array solution. Maybe it's just because my laptop is not good enough, not fast enough, which shows like lower rank in the straight sorry in the runtime as well as the uh, memory. But anyway, I will show you both solutions. So first thing is my solution. So first is my solution. So I define a fixed size array, and in the pane what I do is I have this total number defined, and I loop all the 3,000 elements in the array, and we'll say, okay, if by default all the elements will set to 0, and in this case we'll say if anything didn't say doesn't is not set to 0, and also if the t um, minus the call, which is basically the array I use is the value I store in the array on each element in the array is actually the time that it's being called. So in this case, I will say if the time is actually it's actually within 3,000 milliseconds ago. If it is, then I should increment the total, right? Um, and if and also one and also I need to set that element. After I did this, I need to set the element to basically the value, which is the time that it's being called, and also because I only care about 3,000 milliseconds ago. So in this case, I would just say um, which bucket I need to just let's say if there are it's 3002, so I basically put it into the second bucket of the array with the 3002 in place on the T, because my assumption is there will be always the T will be always increasing, it will always larger. And then I need to plus 1. This 1 is actually uh, the uh, the current call, the current pane, that also needs to be included, because I set the element after I loop the original array. So that's why I need to add this one uh, uh, value. So in this case, the total will be, total plus 1 will be returned. So the time complexity of this solution is, we can say, so this solution is actually O1, right? The reason is I have a fixed size of array, which always gonna loop 3,000 times, no matter how many times the pane you'll have, right? So next thing is space complexity. So I think the space complexity is the same. It's always O1, because it's a constant space complexity, because I have a fixed size of array defined. No matter how long, how many times you call pane, it will be the same, right? So and I checked the LeetCode solution, so I will talk about the LeetCode solution. So LeetCode solution is using the queue, and in the queue you basically say, okay, I want to basically the queue is an interface, and this linked list is actually the implementation function. So it happens a lot. You need to you need to define a queue, but initiate it with a linked list. So that's different from my solution. And in the ping function, what it does is you always add add the t into the queue. It's a first in first out, right? So in this case, when you say the queue dot peak, which means um, at the beginning of the queue, so you feed, let's say the queue, you keep feeding keep feeding items in the queue, right? And the first one will be the peak. It will say, okay, is the peak one still within the 3000 milliseconds range. If not, just pull that and then move to the next. If not, if it's within 3000, if it's not within 3000, you sorry 3000 milliseconds, it will pull that until it's done. Until it's done, um, it will say just return the size of the queue. In this case, it will be 1, 2, 3, 4. Then it will return the the size of the queue. So the the code line is definitely less than what I have here. Probably like couple, maybe 2 lines saving on the code line, but uh, either way it should be either solution. I think it's okay. So the time complexity of this solution, I think in this case, yeah, in this case, I think it will be. Hmm, I don't know. Maybe check the solution here. So the queue, yeah. So the queue solution, uh, yeah. So the time complexity is basically the queue uh, is OQ. So the queue means that uh, the number of queries made, which is actually say how many items that I need to pull from the queue, right? So that's the time complexity. What about the space complexity? So the space complexity, let me just, okay, so the space complexity is actually, okay, is OW, and the W is the 3000, right? Because the 3000 is the size of the window we should scan for recent calls. In this problem, the complexity can be considered as 1, right? Yeah, because we only care about the elements within 3000 milliseconds. So this is, and the queue, in this case, we can imagine that the size of the queue will be maximum, the maximum size of the queue will always be 3000. It will no longer, it will no more than 3000. Yeah, okay. So thanks for, this is the problem of the number of recent calls. Hope the my experience can help you avoid future mistakes. Thanks for watching. See you next time.